That's like,
Yeah.
Hide it.
What's
It
that?
has to do like the N, C, R.
You guys are thinking about combinations, permutations, that's probability, that's at the end. Come back. Sequences and series. It's all about finding the pattern. It's all about finding the pattern, repeating the pattern, and then saying this is going to take way too much time. Let's make a formula for the pattern. What do I mean? Well, sequence separated by, separate terms separated by commas. Okay? Sequence. Separate terms separated by commas. They usually follow some sort of pattern. If we can get that pattern to fit into a formula for the nth term, n is going to be 1 for the first, 2 for the second, 3 for the third, 4 for the fourth. Wait a minute. Question. If we're going to be dealing with formulas based on n, and n stands for the number of the term, like the place in the sequence, can we have n being like, I don't know, 1/2? N equal 1/2? No. Is there a 1/2 term? No. How about a 0.99 term? How about a 4.2356 term? So, you know what discrete means? 1 and a 2 and a 3 and nothing in between. Meaning, if we were to graph a sequence, would it be connected or separate? Separate, because there's a point at 1 and a point at 2, and you can't connect because there's nothing in between 1 and 2 for the x or the n. Does that make sense, kind of? So they're going to be discrete. No sequence will ever be graphed with a connected line because it only has n or x as 1 or 2 or 3. Sometimes we start with n equals 0, sometimes 1, just kind of base. Our minds think better when n starts at 1 as we are trying to get better and better at this idea, because 1 stands for first. Can anybody talk about, though, maybe thinking back to physics, why would it make sense for n sub 0 or n to equal 0 for us to start at 0 instead of 1?
When you have their direction, you have to get from A to B the arrow. So
And we'd like it centered like at the origin, is that what you're
so
thinking?
at the origin, so if it is yes, if it was a function as such.
Okay. Sean is thinking a graph, like maybe it'd be nicer to start at like 0, 0, or start when x equals 0. That's one example. What else?
Like what you said with physics, if something in the rest of the state, it's going to be.
Yeah, maybe if we're talking about movement, you might want to start when it's at rest, and when it's at rest, what would its speed be? Or how about this? Let's thinking about movement. Let's say the movement equation, probably none of you remember that weird, nasty position equation, how we had 1/2 a sub naught t plus b sub naught t, 1/2 a sub naught t squared plus b sub naught t plus x sub naught. You had to plug in all these different points and solve the system of equations. Anyway, that's a really famous physics formula, or general useful one. What is that formula based on? X wasn't in that formula. Do you remember what was? 1/2 a t squared plus bt plus position. Time was my x. Oh, wait a minute. Why would it make sense for time to start at 0? Think about at the beginning, and at the beginning has any time passed. So you could say time equals 0 is the beginning of a situation. Anyway, so sometimes it is going to be useful for these sorts of sequences to start at 0, but for our purposes, we'll probably mostly start with 1 because we're used to 1 being the first. Okay. I want you guys to take the following a sub n formula and the idea that now with sequences, n is like x. And I want you to find me the first term, second term, third term, fourth term, fifth, fourth. Yes, kiddos that turned in their homework spirals yesterday, they're ready at the front after class. What are you guys doing? Plugging in? For n, right? Cool. started working again. Well, you guys had a test yesterday, you didn't know it was working. Let me restart the router, please. I walked too much yesterday. My foot swelled up. Okay, what'd you guys get for a sub 1? What'd you plug in for a sub 1? Ah, n was 1. And when n is 1, plug it in, and you should have gotten first term to be 1, right? Cool. Plug in 2. Hey, some of these aren't going to be hard problems. I'm not be scared of sequences. What was the second term? What's the third term? What's the fourth term? 10. What if I was to ask you right now for the 100th term?
298.
Oh, you could find it? Go team. How could you find it so fast? Exactly. You had a formula. You had a formula, right? So what if I was, hold on, let me check out my notes real fast. What if I was to give you another example? And let's say I was to tell you, given the sequence, if you want, you can just number this as the next example. Let's do 3, 8, 13, 18, 23, 28. This is a fun sequence. What if I was to ask you for, okay, now, you already have a lot of terms, right, guys? How many terms specifically do you have? 6 terms. What if I was to ask you to find a sub 7, a sub 10, and a sub 100? Could you find, you have 6 terms, could you find 7? Where would 7 fall? The next one, right?
Yeah.
And where would 10 fall? The next one. Okay, so hold on, here's the 7th term. Is that okay if I just put that there? Here's the 10th term. Okay. What would, that's supposed to be a page, by the way. What would the 7th term be? Go. How were you able to do that? Aren't you just adding 5, and then adding 5, and then adding 5, and then adding 5? Does anybody remember the special name for a type of sequence where you add a common difference? And we haven't technically written this down, but from Algebra 2, it's called an arithmetic one. Think arithmetic, the first type of math you learn, kind of. And what sort of operation is going on? Addition. Okay. Arithmetic, basic math, addition, basic math. Good? Okay, what's the 10th term? Anybody beat me? Now, this one's I cheated. This one is fun because it's 3, 8, 3, 8, 3, 8, right? So I was able to go 3, 8, and then 3, 8, and run the next 10, so 48. But how else could I have gotten there? Plus 5, plus 5, plus 5, or plus 15? I could have done 33 plus 15. Or I could have filled in all the in-between blanks and done 38, 43, 48. But either way, I can fill in 33 is my 7, 48 is my 10. But when does it start to not be fun anymore? Do you want to do this, let's see, 90 more times? We want to do it in our calculator 90 times and hope we don't lose count. No. What was so nice about the example on the page before that let us jump to 100 so easily? A formula. So can we figure out a formula for this guy? Yes. How? Well, let's go check out this formula real quick. Without even having to memorize a formula, which we're going to memorize formulas this chapter, a few. But without even having to memorize a formula, hold on, pause. Did anybody see a pattern when we were going through this one? What's going on every time? Plus 3. plus 3, plus 3. Does anybody see a 3 in the formula? Me too. How could this 3 next to this n help us with getting more and more plus 3's? How could it help us with getting more and more plus 3's? Well, let's think about it this way. Guys, what was our very first term? 1. So in order to get to the second term, we had to add 1 3, right? From the first term. From the first term, how do we get to the third term? Add 2 3's. From the first term, how do we get to the fourth term? Add 3 3's. How would we get from the first term to the 100th term? Wouldn't we add 99 3's? Wait, how does that make sense? Look at it this way. If I had 1, 2, 3, 4, how many jumps does it take to get to the second term? Just 1 plus 3. How many jumps does it take to get to the third term? 2. How many jumps does it take to get to the fourth term? 3. Look at it this way. How many fingers am I holding up? But how many spaces do I jump to get from 1 to 5? There's only 4 spaces in between, right? 5 total, but 4 spaces, so 4 jumps. So, to get to a term, I do 1 fewer jump, because there's 1 fewer spaces. Yes. So couldn't I also rewrite this guy, another way of writing it, to be instead of 3 times 100 minus 2, couldn't I also have done 3 times 99 plus 1? Now that's weird. So where did they get their formula from? Okay, well here's another way of writing it. You ready? Couldn't we make 3 times 99, 3 times 100, take away 1 plus 1? Because it's 1 fewer jump. And then couldn't we distribute and say 3 times 100 minus 3 plus 1? And this shows us how to get formulas for what we want. We can do the jump times the number, take away 1, plus the initial, whatever the first term is. Now we're going to technically memorize something like this for arithmetic sequences. Right now we're just trying to figure out a formula. I gave you this example and said, hey, we want 100. So we could say, cool, let's start with 3, and let's add how many jumps of the pattern? 5. How many jumps of 5 do I need to get to the 100th from the first? 99. What's the 100th term? 5 times 99, 5 and 4. 495 plus 3 is, I think, 495, sorry. Plus 3 is 498. Double check my math real fast. 5, carry the 4, 45 plus 4 is 49, 495 plus 3 is 498. Did I have to jump 99 times literally, or was I able to say, wait a minute, repeated addition is the same thing as 2 plus 5 is plus 5 times 2, plus 5 plus 5 plus 5 is plus 5 times 3. I was able to rewrite repeated addition as just multiplication. Boom, boom, done, done, done. Okay, that's an intro, let's keep going. So, have we just seen why a sub n formulas are good? Yes. We don't want to jumpity jump to any 100th terms, or 200th terms, or even 20th terms. We're going to get mixed up, we're going to add the wrong number in our calculator. Now on the SAT, kind of all bets are off if you're able to use your calculator. You can't figure out how to do it without a calculator, just, I don't know, jumpity jump. But formulas can be nice and can shorten the workload and can be more precise because we jump straight to the answer. My trash. So even though we can identify patterns, and even though they're good for jumpity jump into the next few terms, that doesn't necessarily mean that we only want to know how to find patterns. We also want to be able to find formulas. We already talked about how to find a pattern. Now, I can't necessarily teach you how to find a pattern. I can show you examples. Sometimes you're going to be adding the same number over and over, sometimes multiplying the same number over and over. Sometimes you're making it bigger by multiplying, sometimes you're making it smaller by multiplying by like a 1 over by a fraction. Sometimes you're making it more positive by adding or multiplying positive, sometimes you're making it more negative by like subtracting or adding negatives. They can be going up, they can be going down, they can be going back and forth and back and forth. Sadly, I can't teach you to identify a pattern, but I'll try to give you enough examples to give you enough practice to be able to do it. But to be honest, the pattern is the easy part. Guess what's the hard part? Not being given a formula, but having to make up formulas gets really hard. So I'm not going to really test you on that too much. It's good practice to kind of play with a little bit, especially if you're thinking of going on in math at all. But it is a hard thing to do to make up formulas. So we're going to start with some special sequences. The arithmetic and geometric sequence. Arithmetic, we're adding by a constant. Geometric, we're multiplying by a constant, a common constant, by the same one over and over again. And we'll look at their formulas just to kind of help us out a bit. So, before we go there, let me just kind of re-emphasize how it can get hard. How it can get hard. I don't want you to start with finding a formula. I want you to start with find a pattern. Can you guys find a pattern? Go ahead, take a second, write it down first. Give everyone a chance to think about it. Remember, I just said finding the formula was hard. Just trying to kind of prove a point, just a little one. Let's see if we can find the pattern first. But remember, if I was to ask you for the 100th term, even if we can find a pattern that's good, but not super helpful, not as helpful as if we can find a formula. But let's start with the pattern. What do you guys see? Add consecutive odds. Starting at I know it's warm, the air should be 21 in a second. Does this sentence describe what's going on? Start with an initial term of 0 and then add consecutive odds starting with 3. So 0 plus 3 and then plus 5 and then plus what's next? Good. Is this pattern good enough to maybe find me, let's see, how many terms do we have up there? Yeah. So we have a sub 1 through a sub 5. Would this pattern be sufficient for me to use in order for me to find, I don't know, like a sub 6 or maybe even like a sub 8? Could I use this pattern? Yeah. So I could say, all right, well, 5 would be the next term, right? Because this is the a sub 1, that's the first term, second term, third term, fourth term, fifth term. If I wanted the 6th term, I would just go one more, true? Yeah. If I wanted the 8th term, how many more would I go? I would go here. Okay, that's not too bad to follow the pattern. So you guys tell me, what's the 6th term following the pattern? Yeah, because you would add 11 and 24 plus 11. No big dealio, 35. The 8th term. Well, yeah, we would have 35. We would need to add not just 13, but also 15, right? So we would do 35 plus 28, or we could do 24 plus 39, either way. And we end up with 63. Double check my mental math. Good. See, patterns are good, but they're not best. And here's the reason why, once again. What if I was to ask you for a sub 100? Do we want to jumpity jump there? No. Would we love just plugging in 100 to a nice neat formula? Yes. But what's the dilemma? Now we're needing to answer the question, fine, what is the formula? And not just any formula, what is the formula for the nth term, if I can spell formula? this just got to be a struggle. Because we have to figure out a formula that says, hey, no big deal. Plug in 1, you get 0. Plug in 2, you get 3. Plug in 3, you get 8. Plug in 4, you get 5. Plug in 5, you get 24. Plug in 6, you get 35. Ugh. Well, 1 minus 1 is 0. Maybe it's just n minus 1. Question, what's 2 minus 1? Not 3. Okay, well that's it. Okay, yeah, so maybe we could do something like we did before. And we could do like, okay, let's start at 0, and then let's add, how do we get odd numbers? N. Nope, that'd be 1, 2, 3, those are odds and evens. 2n. 2, 4, 6, 8, oh, those are evens. How do we get odds? 2n plus 1. Maybe. Oh, but wait, hold on. N starts at 1, 2 times 1 is 2 plus 1 is 3. That would be for the first term. I don't want that. So maybe what Ella was saying with 2n minus 1 makes more sense. So 2 times 1 minus 1 would be 1. 0 plus 1 is 1. But that didn't work. Maybe if I do 1 minus. That works for the first one. If n is equal to, not 0, sorry. If n is equal to 1, 1 minus 2 minus 1 is 0. Yay! If n is 2, 1 minus 2 times 2 is 4, and 4 minus 1 is 3. 1 minus 3, oh, this isn't working. Now here's the struggle, guys. The nth term formula has nothing to do with the odd pattern that you saw. Did anybody figure out that all of these numbers are very, 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 very near perfect squares? So near, in fact, they're only 1 away. The a sub n formula is n squared minus 1. What? Oh, what's 1 squared? 1. Take away 1 is 0. What's 2 squared? 4. Take away 1 is 3. What's 3 squared? 9. Take away 1 is 8. What's 4 squared? 16. Take away 1. That was hard. I know. Hence, one more time, why the point is not to teach you how to come up with formulas, even though it's a good skill and it's like a puzzle just waiting to be found. But instead, just to make you realize these formulas, if they can be found, are oh so helpful. A sub 100, just plug in 100 square and then subtract 1. What's 100 squared? 10,000. 10,000 minus 1 is... It's 100 times 100, add on 2 more zeros, right? Dun, 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 dun. One more time. Is this meant to be easy, finding the nth term formula? But can it be helpful? Yes. Let's go talk about some special ones. Look at this, but don't write it down. Look at this, but don't write it down. Just something for you guys to keep in mind really, really fast. If you're ever giving an example and you're supposed to find a pattern, couldn't you guys say maybe like times 1/2 times 1/2 times 1/2, right? But look at this example. What if you were given this one? This one does end up actually being times 1/2. The a sub n formula, which is this little guy down here. A sub n ends up being 1/2 raised to higher powers. That's what that little n is for. That one is the true times 1/2 times 1/2 times 1/2. What's going on down here? Doesn't it look like times 1/2 times 1/2, but you have to keep on checking to make sure everything they gave you works? Is this one really times 1/2? No. So be careful. Just because you see a pattern maybe for the first couple terms doesn't mean it repeats. This one actually has a much, 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 much more complicated a sub n formula. Like, there's no way that you would be expected to find. But just the idea is some sequences can look very, very similar, so just watch out. Watch out. That's all that page is for, okay? All right. The way that we've been talking about sequences, we've been saying two things. We've been saying, okay, let's talk about the jumpity jump jump pattern, finding the pattern and repeating it. And actually, there's a snazzy math term to that process, and it's called recursive, defining sequences recursively. finding recursive formulas. If you want me to, I can write it down. This is our jumpity jump jump one. Or you can think jumping with the pattern. Does that make sense? Finding a pattern and then jumping with it, going from one term to the next, following the pattern, repeating the pattern over and over and over again. That is working with sequences recursively. Working with sequences recursively. Just a snazzy math term to the process we've been doing. So just think about that jumping with the pattern, pros and cons real fast. And we basically already kind of talked about it. What are the pros? Usually patterns are easier to find. Usually the pro is that finding the pattern is easier to find, easier to identify, easier to explain. The cons? Not good for, why am I saying not good for high values event? That was for the high. It was unintentional, I'm just thinking about Tuesday. Why is the jumping with the pattern not good for high values event? Yeah, it takes forever, you could lose count in your calculator. Now, are recursive patterns good for computer programming? Sure. Why? Why is it good for computer programming? Can you tell a computer to do things repeatedly until it reaches a certain set amount and it can keep track of exactly how many intervals, how many jumps it's doing and do the computations very precisely? Yes. Recursive programming, recursive formulas, recursive ideas are great for computer programming because we can make it do all the work quickly for us if we can figure out how to talk to the computer, take programming. But there's a lot of free programming stuff online. Anyway, coming back. But recursive isn't so good by hand. But how do you talk about formulas recursively? Here's an example down below. Even though doing this by hand is not good, if we can tell our calculator to do this, which we can, there's this thing called a SEQ, sequence mode. Not just function, not just parametric, but sequence mode. We can tell our calculator to do some of these things. Now, one thing I need you guys to add in real quick, this little K down here needs to actually have a -1. That little K down there actually needs to have a -1. There is programming in your calculator that allows you to describe a recursive sequence to your calculator. You're going to go find the SEQ sequence mode. And when you find the sequence mode, there's a way to say, hey, here's the first term and here's the jumpity jump jump. Wait, what? To get to the second term, you can plug in the formula. You do -2 times the a sub 2 minus 1, the first term, which we know to be 14. We pause. And we can see every time we're just jumping by the pattern of -2 times. Kiddos, we got a good start on 9-1. We're going to finish it tomorrow, which is why this homework isn't due until Monday. We can get a head start. People with homework spirals that you turned in later yesterday, go get them. Go get it. And I'll see you guys tomorrow. Unless you have questions, you need to come in.